Hello there. This is stream number 14 in my Making My Own Keyboard series. So I'm going to continue today what I was doing yesterday, which is working on this interboard communication between these two guys. Right now they're using a rather inefficient text line style interface, and I want to make it kind of a nice binary interface. I was working on this yesterday, and I am going to mostly work today on this encoding scheme to be able to have each board recognize when a message begins, because we're going to run into this if we don't do this properly, where we might miss the beginning of a message and then be completely out of sync and not never really synchronize. So looking for this FF byte at the beginning of a message will help us like resynchronize, like find the beginning of the next message. It's just that we might want to have that byte in the middle of a message, so we're going to have to escape it. And this is the scheme that I picked. It's just rather arbitrary. So I'm going to work today on this encoding scheme where we're going to add FF bytes at the beginning and end of every message. And if the content of the message has FE or FF in it, we're going to insert these extra bytes. And we're going to apply that to what I was doing yesterday with this message enumeration. These are the kinds of messages that can go between boards and between the host and the primary board. And yesterday I had coded up using bin code the scheme to encode this stuff, mostly done by that library and really just testing it here. So like, for example, a log message that says hello is the byte 2, which is standing for the 0, 1, 2, so the log variant, and then 5, which is the length of the string, and then the characters in the string. So we proved with the unit tests that we can turn a message into byte string and then turn it back into a message. So one thing I noticed right before the stream is I think these tests for encoding messages kind of along with message itself. So I think first thing I want to do is kind of move this stuff. So these tests I'm going to take out like that. Cut. I had to pause for a second to remember what the cut key is in this keyboard. Paste here. And then back here. This is the top level of the IBC library. So I think this just stays as it is, right? Let me make sure that this still works. So I should be able to go to the IBC and do cargo test to run the test, and it should run them all. Cool, we have 8 tests passed. Let's check that in. Start the night off with a commit. Hey there, 715209. How are you this fine morning / evening / midday / midnight? Move unit tests for IBC message type. Alrighty. So I was thinking before the stream that this technique of doing the encoding, I can make that into another type that does this. So a type representing this is where I'm not sure what the name would be. Good, wasn't expecting to see me today. Yeah, I have a World of Warcraft raid from 8 to 10, and from 10 to midnight is sort of a free time for me, so I felt like working on this some more. So it might not be a longer stream. Might just be like an hour and a little bit more than an hour, but then I don't have to wait a whole day. So probably a longer stream tomorrow, but a shorter one tonight. So I need a name for whatever this is, this technique of encoding the message so that we can easily find the beginning and ending of it. Maybe I can call it something like framed message, because that's what we're in a sense doing. We're framing the message with these FF bytes. And then we can have this type like have a method to like recover one of itself. Or maybe just have it recover a message by just repeatedly scanning bytes. So this is really more than a framed message, isn't it? It's like a framer, like a message framer. Message framing? I'm trying to think of a name for this. How about we just go with framing for now? So mod framing. And we'll have a struct framing. So, depending on if we're constructing a frame or destructing it, I'll have different state, right? What if we're constructing the state for framing? I think we would go straight from a message to the output. I really only need state here if it's going to be the other way, like deframing it. So there, we kind of need to have the bytes we have accumulated so far. Yeah, the bytes we've accumulated so far, and then maybe what state we're in, because we can be in one of two states. We could be waiting for the first byte, or we could be waiting for the second byte of this escape sequence, right? So that tells me I probably want to have an enum, like escape, or state. Let's just call it state. It'll be a local type anyway. So one will be like next byte, and then the other one will be called escape. That's what I'm thinking. So this would have a state. And it would have like the buffers, like a message or something. Buffer. Vector of bytes that we've collected so far. Off the top of my head, I think that's all I need. But we'll find out. So this needs to be public, because we're going to use this outside of this module. So framing. My idea was to have like at least two different methods. One is to like take a message and create a frame out of it, so to speak. Codec? Like a, yeah. Okay, I like that name better. We're gonna go with codec. See, everyone else is better at names than I am. Escape. Function 2. It's not a function. Try again. Codec. Beep beep. And then here, codec. All right, I'm already liking it better. Okay, so encode decode, right? Encode is the easier one. And I don't need any state with this, right? So I can just have it go from a message to some bytes, right? So to a vector of U8. Hey there, Endured. How are you doing today? I'm guessing it is 8 o'clock in the morning for you. How would I know this? I don't know. I'm just guessing. All right, so we were going to have like... Well, can I do this without having a mutable vector? Can I do it in one shot? Maybe with an iterator? Possibly? So if I want to do this iterator style, it would be something like what I was doing in the tests here, where I do this encode, like encode to vec. Okay, I need to open my browser and get the bin code manual out, because I don't remember this stuff from yesterday. And 45 seconds, yep. I like to say 715209. I almost have the numbers memorized at this point. All right. Okay, I need to remember to select the release candidate for 200. That's where I got kind of confused yesterday, because by default, it picks the last real release. And we're on a release candidate. Okay, so encode. It'd be nice if I could encode into iterator, but next best thing I guess would be encode into a vec and immediately iterate it, right? It is 11:01 and 52 seconds right now. Hey there, Dr. Padawan. How are you today? The technologist. Oh, hello, technologist. Really interested to see how you solve this. You mean solve the framing issue or the encoding issue? This is the issue I'm solving today. That to send messages between these two boards and synchronize the receiver with the transmitter, we're going to begin and end every message with a special byte and then have encoding so that the payload of the message can have that special byte encoded as a 2-byte sequence. Nice. I think it's just bare bones. Maybe it's nice. I don't know. I'm not a really good judge of these things. Okay, so if I do something like bin code encode to vec, and the value is the message. And I think for config, we're just using this standard config, right? Kind of weird that we have to pass that for every time we call the thing. My copy paste skills aren't very good tonight. Copy and paste. There we go. Okay, so into iter. Essentially, I want to map this, right? I want to map every byte to something. And then in the end, I'm going to collect it. Right? And I want to actually put something in the front of this, right? It'll be like iter, was it core iter? Once. That special byte at the front, right? And then dot to chain iterators, it's just chain, right? So we're going to chain this iterator and then chain core iter once ff, right? Okay, message needs to be imported. Jellyfish dance. What's the encoding you've thought of? This is the encoding I've thought of. Very simple. We're going to put an FF byte, the front and back of every message, so that when the board first starts up, it can just throw away any byte that's not an FF until it sees one, and then it knows it's either at the beginning or the ending of a message, and it just keeps reading until it gets a non-FF, and it's like, okay, this is the actual message content. And for those cases where the FF byte would naturally be in the body of the message, we're going to encode that as FE02. And then tell FE02, which means FF, from an FE, we'll have FE be FE01. So hopefully that makes sense. So any bytes from 0 to FD will just be encoded as is. If we see an FE, that means we have to read the next byte, and if it's a 1, then it decodes as FE. If it's a 2, it's an FF. If it's an FF, we know it's the beginning or the ending of a message, so like the frame beginning and ending markers. So if we see FE and then any byte other than 1 or 2, it's undefined. So I suppose we would just reset our state and say, okay, this message is obviously corrupt. We'll wait until we see the next FF byte. Actually, that reminds me, we need to tell the difference between if we're in the middle of a message and if we're searching for a message. Off the top of my head, I'm thinking if buffer is empty, is that good enough? Probably not. So we probably need some kind of like a flag that says whether or not we found the beginning. How about frame found? Easy, right? Sounds like advent of code. Hey there, Metro. I guess it's at advent of code that I've constructed for myself to build the protocol for this keyboard. Since there was a special value like FF for startup encryption that would contain normal FF. Yeah, what this is kind of inspired by are other formats that I've learned about in the past, where you have something called like a start code or a synchronization pattern or a sync word. And if you just start reading a stream that's in the process of being sent and you don't know where the beginning is, you just read it until you see one of those things, the start code, sync word, synchronization sequence, and then you say, okay, I at least know that after this is the beginning of a message. And everything before, well, it's incomplete. We'll need to ask for it again, or we'll just have to go without it, right? So it's kind of inspired by the stuff I've seen in the past. Okay, what's the deal here? Okay, I think it's just confused because I don't have anything there. What if I just type something in there? Okay, cool. So it's just that I need to actually generate a byte here. So we're going to produce an iterator, right? I think what I'm going to do is have this generate an iterator and then flatten it. Let me think about this. So if we have an iterator of iterators and I flatten it, so would this make sense? Like, just to put something in there as a placeholder. Let's say we just put the byte in by itself and we didn't handle the FE byte. Does that make sense? I don't know. I don't think so. I need to get my types correct here. Type mismatch resolving a once of a vec as an iterator where the item is an integer. I think it's because of this flatten. Isn't quite right. Creates an iterator that flattens nested structure. Right, because we're going to have an iterator of iterators. Because we're mapping each byte into an iterator that produces one byte. And I thought that this would work, but maybe I'm wrong. Actually, I think that goes outside of this. There we go there, right? No, not quite. What's the problem here? Oh, because the types aren't the same. Yeah. Let me rethink this. So we have iterators of bytes, right? So we start with an iterator of 1. We chain it with an iterator of some things, and then another iterator of 1s, and then we collect all of that. That's fine. Thing is, this byte might make either 1 or 2 bytes output. So I was thinking, okay, what if we return? What if we map each byte to an iterator and chain them together? Well, if I made this be too deep and then I could flatten at the end, I think that would work. I just need to type correctly here. So let's try this there and this there, and then move this flatten to there. Would that work? It's an iterator of iterators of bytes, right? How come this isn't working? Traits aren't satisfied. Oh, there a byte is a vec? Let into iterator would give me bytes. Oh, that gives me a result. Ooh. Okay, I think we can safely unwrap that. There we go. I got it working. It's sort of weird that I have to say once, twice here and here, but just to make the types match, right? An iterator of iterators, and then we flatten it to collect it into bytes at the end. Okay, so then this would be like matching on the byte, right? So we would say match byte anything else like byte is that. I'm missing something. I'm missing that character there. Okay. So if it's here's where we got to do our special cases, right? If it's a FE, then I need to make core iter once FE and then chain it, right? With a 0, 1. And then an FF, I said, was going to be an FE followed by a 2. Like that. Okay, they're incompatible. Why? Oh, I can't do that? They have to be the exact same type. Okay. Well, I'm not sure how to do this then. Let's catch up on chat. Remember something similar? Okay, I see what you're saying, Endurin. Special value to start encryption. The normal have to be doubled. Yeah, I mean, it's kind of like escape characters, right? You know, when you make a string, like hello, and if you wanted to put like a backslash, that's actually an escape character, so you double it. And so that ends up being a single backslash, because if instead you had an N, that would be a new line. It's kind of like that, where I'm saying like 2 characters, and the second character tells us which thing it turns into when you unescape it, right? So FE becomes kind of like the escape character here. Okay, the problem is that every arm of the match has to have the same type, and obviously these have different types. So how do I fix that? Okay, off the top of my head, instead of doing this at iterators, we could just build like a builder pattern with a vector. Maybe that's just simpler. So this would be encoding or something. Equals vec new. Actually, we can just start it off with the FF character in there. And then instead of this into iter here, we would still have this, but we would just say for byte in that. And then we would still do this match, right? Okay, and at the end, we're going to do encoding push. Isn't there a push for vector? I probably just need to fix my syntax errors. But yeah, at the end, we're going to push another extra FF and then return the encoding. So, sorry, Musin, we're not doing the iterator approach tonight. Oh, vec is not imported. It didn't understand what vec meant. Now, what is the error? Can't find it. I thought I... Oh, is it like confused? I need to use alloc vec and then do that. Yeah, that's what it was. Okay, and then what is... Yeah, we don't want to do this chain thing, right? So byte would be... this is all be doing encoding push, right? Only here we're pushing the byte. Okay, for these... pushing an FE and then pushing a 0, 1. Okay. So an FF is a 2. Okay, so that works, right? This is the Rust, like, imperative programming style of how we encode a message. And we can kind of see it makes sense. There's the beginning of the message, there's the end of the message. The body of the message is we encode our message, and then for every byte, if it's an FE, we have to escape it. It's that sequence. If it's an FF, it's that sequence. Otherwise, we just put it as is. Normally have to start transmission and end transmission. That's what we're doing, yeah. Yeah, so the numbers we pick, FF, FE, it's all arbitrary. We're using a window be an option? A window of size 1? It's the construction of the output I wasn't sure how to do, because sometimes we push 1, and sometimes we push 2. So if I, you know, was returning something for each match arm, we would probably be a different type for every arm, and that won't work. The original data will be 05FF0103. That resulted in the 1 getting lost. Yes, so the 1 would be... No, it's not that the 1 would get lost, it's that the 5 would get lost. You would skip the 5 because you haven't seen an FF yet. Then you see the FF and you'd be like, okay, the next byte is the beginning of the message. So then you would read 1, 3, and you keep going until you see an FF, which marks the end. And then you say everything between the two FFs is a message. So the 5 gets lost because you don't know where the beginning of the message that 5 belonged to was. Well, the data being encoded here is FF5FE010103. Yeah, we can't forget the beginning and ending characters. Chain flatten work inside the match arms. I don't know. Maybe. No, it has to be exactly the same type. The problem is that chain and flatten both actually return a new kind of type. So the type is going to be slightly different. Yeah. It's Rust is very type strict. I'm just going to keep it imperative for now. So, hey, let's do the right thing and make a unit test for it. I should have done this first, right? Test-driven development and all that stuff. So let's do it. It's never too late. We're going to make a test module. Let's not presume we need that. So let's do just in a simple encode. So the encode will say let message equal message log string from hello. Actually, let's purposely put in those two characters. So backslash x f e and then backslash x f f, right? So it's HE and then FE byte and then LLO. Okay, this won't work because it's a string, so I need to make something that actually has a string. Well, the program let me do a string, right? I mean, bytes. Let's do program instead. So then it's a vector. then just a 0. Okay, like that, right? All right, and then we're going to say let encoding equal codec encode message. We can borrow this message. We don't need to consume it, right? Yeah, so borrow the message. And we would assert equal, I guess, encoding matches a certain vector again, right? So largely the message stays intact, right? Only we have extra FF bytes in front and at the end. And this FE gets a 0x01, and this one becomes an E, and then it gets a 0x02, like that. So that's the FE there, and that's the FF there. So let's just run the test. We failed. How do we fail? Oh, I forgot. There is a length of program. So 1, 2, 3, 4, 5, 6. There's a 7 in there. Yeah, and then there's the message type. Yeah, so there's a 03, 0x07. All right, let's run it again. Okay, cool. It passed this time. Great. Let's make a decode. Okay, so for decode... Oh, hold on. I want to have another... before I do decode, I want to have another test where we're encode with sync. Or it's without sync? So this would be... I have... Oh, wait a minute. I'm getting confused. That's when we're decoding, right? When we're encoding, we're always in sync. So it'll be the decode... we'll just put it into decode, where we kind of turn this around, and this is the vector for the encoding. So that goes there, and that begins... That's what we start with, right? That goes there. Right, and then... this doesn't need to be a vector, because I think the way I'm going to do it is I'm going to pass it in as a whole slice, or maybe just one byte at a time. So it can just be an array, right? And then the message is going to, we'll have not a message, but a codec, right? Let codec equal, and this needs to be mutable. Codec new, and then basically we're going to feed in one byte at a time. And we're going to wait until it generates a message. So 4 byte in encoding. If let some message equal codec dot decode byte. Then I don't want to do this. Just do the assert here. Yeah, let's record if we even got a message. So let mute got message equal false. At the end, we'll have assert got message. You don't need configuration test. I do. I think I just missed it. Thank you for the observation. I don't need it to run the test now, but if I don't put it there, it'll get built into my library, which is unnecessary, right? Right, when you think about it, this module only is compiled for the test configuration if I do that. But if I do that, that just means the module is always there, even if we're not testing. So it'll still work, it'll just have a lot of dead code and comes along for the ride. Thank you for catching that. Okay, so if we get to here, then got message equals true. And I'm going to want to do the assert equal. Message should be the original message that I had up here. That. Okay, and then I don't need this. Okay, so a couple problems. We don't have a decode, and we don't have an yeah, we don't have this decode yet. So Rust Analyzer can't tell us that because of a shortcoming that it's a multi-platform workspace, and Rust Analyzer, I can't tell it to check the test target because, or variant or whatever you want to call it, because if I did, then it can't build the ARM stuff. So I have to do it here. Well, just running Clippy here should do it, right? If I do...
Beep, 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 beep.
Well, let's just run tests. Test. It's going to say where all my errors are. Okay, there's no new. That's the other one. I need a new, and I need a decode. Oh, this should be mess. This shouldn't be here at all. Wait a minute. Yeah, this shouldn't be here at all. There we go. My watch is telling me I have a half an hour left to stream before midnight. All right, let's fix the problem with new. Let's make a new. Right here. Self. So just return a self. Fill struct fields. Frame found will be false. Buffer will be vec new. State will be state. Actually, I can combine the state with the frame found. So this should be like state searching. Let's call it that. And I don't need frame found. So searching. Don't need that. I like that better. Hey there. You're just a bit. How are you doing? Today I'm implementing this simple encoding so that I can have the boards synchronize with each other, the transmitter from one end and the receiver of the other. So we're like encapsulating messages with a special byte, and then to prevent it from being emulated in the middle of a message, we're using a 2-byte encoding, like an escape sequence for if we need to represent FF, it'll be FE02, and then an FE by itself will be FE01. So I'm implementing this kind of like simple codec right now. I'm doing great. At the end of the last stream, I had the message serialization working. So we have these kinds of messages that can go between the boards and between the main board and the PC, and has all the information I need, and I have tests that verify I can both encode and decode these to bytes. So now I'm just adding this extra like line codec or frame codec or whatever you want to call it. Verified that we can encode it, so this message, this program message to program this hypothetical program sequence has the FF at the beginning and the end, and then the internal FE and FF are encoded properly. So now we're writing the decoder. The idea I have is that we're going to put junk in front of this. So like, let's put some junk here. 14, 7, I don't know, it doesn't matter what I put here. In fact, I could even put an F E here, and I won't care, right? It's this FF triggers the beginning of the message. So these, it should be still in the searching state and then just discard them. Didn't finish the last VOD. Notice I had some problems with cargo. I fixed the cargo problems. What it ended up being is I was trying to use SIRD, and the way I was using it was pulling in the standard library. And the moment you pull in the standard library by accident for a no standard cargo or a crate, you get an error at the top saying there's no standard library available, and then you get thousands and thousands of like irrelevant errors that were both causing Rust Analyzer to grind to a halt and causing like an overflow of messages when I ran it on the command line. So I fixed it by using the release candidate of bin code, turning off the default features, and basically not using the standard library, but using a serialization library that doesn't need the standard library. And then it started working again. Hey there, Phil Powers. Rename your Git branch trunk so you can put all this junk in the trunk. When we used to use, was it CVS? We would call the main branch the trunk, which makes sense if you're thinking about branches of a tree. The main branch would be the trunk, right? Yeah, I did fix everything. The only thing that we can't get working right now with Rust Analyzer is it will not run Clippy for the test module, because this configuration test, it does not try to run the analyzer over. So I could make a bug here, like I can just put an X there, and you'll see that I don't get any red squiggly here. I won't know that I made a mistake until I run cargo test, and then it'll say, wait a minute, that's undefined, right? So that's the only thing that we're kind of missing right now. And I figured that's an okay compromise, because the unit tests are going to be hopefully pretty simple and not complicated, and if there are errors, that should be easy to fix them, right? All right, so then I have new done. It's probably going to complain about decode. No function called decode. So let's write decode. Let's put it here. So function decode. It's going to take reference, mutable reference to self, and it's going to take a byte, right? And it may, so option, return me a message. Right? Let's just put none in there for now, make sure it builds. Should build and fail, right? Yeah, so it builds, but it fails because we did not get a message. Perfect. So I think it all comes down to the state we're in, right? So I kind of want to match on the state we're in. Self.state. Fill in the match arms. So if we're searching, we're basically waiting until the byte is 0xff. So if byte equals 0xff, then self.state equals state next byte, right? And otherwise, just ignore it. At the end, let's just put a none here for now. Make sure I don't have any compiler errors. Okay, so if we're in the next byte state, it depends on if the next byte is one of three things, right? So we're going to do a match on the byte. If it's an FF, then we're going to do two things, right? That means it's the end of the message. So we're going to move back to this searching state. And we're also going to emit the message, right? So we're just return it immediately. Return self.buffer. I need to remove it out. So can I do a take? Well, can I make that an option or a cell? What's the best way to do this? Option? Actually, what I'd like to do is put the buffer in there. Let's not get ahead of myself. Yeah, Subversion used to do that too. Yeah, in Subversion, it's called the trunk. That's right. Maybe it was Subversion. CVS didn't have the same concepts of branches, did it? Make unit tests for the unit tests? Yeah. I think we would have gone down a rabbit hole if we did that. A recursive unit test generator. Yeah, I think that's not something we want to do, right? Okay. If I want to avoid a copy, really, then I kind of do want to make this an option to start with. Then this can be none. And then when we get into the next byte state, we can actually set it up at this point. Buffer equals sum vec new. And then here we can just do buffer.take, right? Will it not let me do that? Oh, shoot. We don't want to... We want to take it out and then we want to decode it. So that was, yeah. This decode from slice? Is that the right one? Sure, decode from slice. And we get a message size. Let me just copy all of this. So let message... Where's the message go? Hold on. Oh, we get two things. I'm reading this wrong. Oh, this is a bad name. I should fix that. It's not really message size. It's like message with size. Well, really it should be if let. Okay. And then we have a message and a message size, right? If that is true, then we're going to here itself buffer dot as ref dot is actually that's good enough, right? As ref unwrap actually. Okay, if it decodes properly, we'll take it out. Well, I can just... I don't need to actually take it out. I can just say equals none. We're not going to return that. What we're going to return is the message. Yeah, we don't need the message size here. It doesn't really matter. And what's wrong with this one? Okay, non-exhaustive pattern. We can fix that. So then, if it's 0xFE, then we're going into the escape state. Right? And if it's anything else, then it's a byte. And we're just going to push it as is, right? So it would be just self.buffer dot as ref unwrap dot push byte. Okay. What's wrong with that? Can't borrow it as mutable. Oh, as mute. There we go. Fuzzing win? Aren't I fuzzy enough? Need to call Gamozo. I'm missing the meme. I don't understand the meme. Okay, in the escape state, it's kind of like this, only we interpret that second byte a little bit differently, right? If it's a 0 1, then we're going into the next byte state, and we're pushing in an FE. So let's just copy this. Right? And if it's a 2, we're pushing in an FF. If it's anything else, it's an error. So I think what I'll do if it's anything else is we'll just go back to searching. We'll just basically discard the message. I mean, I could log a message here saying like corrupted message encountered, but I'm not even going to bother doing that. All right, let's see if it passes my test. Nope, it failed. Panicked on 130, so we did not get a message. It should have gotten a message on that last FF, right? Unless I made a mistake here. In the next byte state, if it sees an FF, it should go to searching, and then if it can decode it, it should return the wait a minute. That is an option. Oh, right. This should be some message. I had the type wrong. It's very sensitive. This is a generic, so this type needs to be message. Okay, let's try again. There. Passing. I love passing. Don't you love passing? Out of curiosity, but are you going to include any type of error correction to the messages? I wasn't going to bother because the link between these boards is going to be pretty short. It's a fairly slow communication link. I don't expect any errors. And even if there are errors, then all I may be missing is maybe I miss a key or something. If I ever see that, then I'll rethink my decision. I haven't seen any errors yet, like programming. We've had this board send to this board like 64 to 72 kilobytes of programming data and haven't seen any problems with it, no corruption so far. So I wasn't going to bother with error correction. Make the error there would have been a corrupted message here, but you're too lazy to write that. No faster link. I tried increasing the speed between these and I ran into some trouble. And then I realized I don't really need it to be that fast. 115 kilobaud is plenty fast enough. Chaos Magic Keyboard. Yeah. Just try to hit the keys. Maybe it will work. Maybe it won't. Okay, cool. So we have our line encoding and decoding. Excellent. I should test to make sure that we can decode several messages, right? So, let's make 2 messages here. We'll put in a greeting message first. Let me annotate this a little bit. So this is like some incomplete previous message. Program message. All right, and then here, some incomplete message, and then we'll have a greeting message. All right. So the greeting message is just a 0, right? Yeah, the first entry. And then an FF. Okay, I don't like how it's auto-formatting everything. How do I get it to stop that? Extra return there? I don't know. Is it if you do this? Wait. This style comments, it will not auto-format. No, it still wants to auto-format it. I'm trying to defeat the Rust FMT algorithm. I don't know if I can do it. I don't know how to do this. What if I put in hold on. I should have a complete thought before I say something. Maybe I'm just gonna give up. It's like that goes with that. Oh, what if I do this? What if I take this and put it after? Oh, that's better. Like that goes after. And then like these move down. Yeah, that's good enough. Okay, so here we're going to expect two messages, right? We'll say like get, got, greeting. Well, let's copy this. And got program. We're going to expect we get both, actually. Well, hold on. We'll check this at the end. Here we'll say if got greeting, then we're going to say, well, really the assert should go after, right? And this has got the program message. Otherwise, we're going to expect the program the greeting message. Greetings, Earthling. So if we already got the greeting message, expect the next message to be a program message. And expect that we get that program message by the end. If it's not the greeting if we haven't gotten the greeting message yet, expect that. So let's see if this works. No, I have an error. There's no greetings. Probably because it's a singular. Try again. It doesn't like the parentheses. Okay, it's called decode. I need to call it something else. How about decode twice? Okay, it passed. I have a warning about unnecessary parentheses. Let's fix that. So interestingly enough, when I run the test, it does take the warnings and put them back in as yellow swigglies. So that's better than nothing. But hey, it works. So we can use basically the same codec to decode multiple messages in sequence, which is really nice. Rustlang, RustFMT tips, RustFMT skip. Oh, really? Let's see how that works. So what is it basically saying? Just ignore this formatting. I like it how it is kind of a thing. For things you don't want it to mangle, skip. Thing is, I do want it to format it. I just don't like how it formatted it. If I tell it to skip it, then I'm worried that if I needed to indent or outdent it, it won't do it because this is heavy-handed. It's saying always skip it. I kind of like something in the middle, something like you're allowed to indent this, but don't rearrange the lines. But that's good to know. Thank you for that idea. Maybe put an empty comment before that. I think it would just eat that. Some reason thought it was going to be in the megahertz range. Megahertz. I tried megahertz range and it was too fast, I think. For this UART on this guy is only like 32 or 64 bytes deep. So if you run it in the megahertz range, you have to poll it fast enough to not let it overflow, or it has to be interrupt driven, and I'm doing neither. We might end up spending too much time processing the USB port here, and then overflow the FIFO on this UART. So that's another reason I kind of have to keep it slower, because it's not interrupt driven. We might be, the single core that I'm using might be distracted in processing something else at the time. Which is ironically what actually did happen when I did the programmer, because while we're programming the flash, we can't service the serial port, and it was overflowing. Okay, I'm happy with this. I think it's time to first run all the tests, and then check it in. So we add line codec, line framing codec. All right, now is the time for we're actually going to try to use this. The problem I'm anticipating though is when I change the message format to this binary thing, that I'll have to program it with the old text line style, and then after it's programmed, we have to update the monitor to use the new format. Otherwise, we won't be able to continue to program it. But maybe I can do this incrementally. Actually, I don't think I can do this incrementally. But, I mean, let's go look and see. Is that a rusty screwdriver you're sipping on? This is a mango rum concoction. Haven't used your Raspberry Pi Pico that much since it can't drive an external ADC? Well, don't you have access to the 5 volt? Well, if you're plugged into USB, you have access to 5 volts there. That's what I'm intending to use to drive the LEDs on my board. I'm not using the 3.3 at all, actually. Okay, firmware. Source. Mango rum concoction sounds great. Yeah, picked it up from the Virgin Islands. That idea. Okay, so I know, we'll just start with the greetings one. Now, the problem is that on the receiver end, we're receiving more than just greetings, right? We're also receiving programming. So, And this is from the controller state. So this is how we also program the main board. So we have to change it all together. Okay. Well, let's just bite the bullet then and do it. So input, right? Next. Control buffer. So we don't really need control buffer to be a vector anymore, do we? We would call this the control codec instead, I think. So I'm just going to call it control codec. And we're going to call this IBC codec. And I just realized I forgot to make it public. Let's go do that. So we want all of these methods to be public. Okay, it already is public there, but we also need to export it out here. Pub use codec. There. Now back here, I should be able to import it. Oh no, I don't need to import it because I'm being explicit about IBC. You get the 5 volts from the V-bus is really noisy because of the buck boost converter that Pico has integrated. So on this Raspberry Pi, it seems pretty stable, but I haven't looked at how noisy it is. It might be because, yeah, I haven't really looked too close at this board, but they probably have capacitors to clean up the signal. So can't speak about the Pico though. You design a board with proper filtering. When in doubt, add capacitors, right? Okay, so this would be IBC codec new. And this is control codec. All right. So what is this here? This is if we receive data from the peer, right? So then this would be for byte in bytes. And it would be if let some message equal what am I trying to say here? What is this type of this? What's this command? Oh. Yeah. Oh, I forgot program is a size. Oh, shoot. I need to split up the program into pieces, don't I? Yeah. Program I had divided into, you first get the size, and then you're receiving sectors. Right. Okay. So, I gotta go fix that. If I fix it, then command really is my ABC message, right? I think so. So then, back here, if this is self.control codec.decode byte gives me a message, then I'm going to want to handle it, right? What's this commands? Process control buffer. Does this go away? I think this all goes away in the end, right? Yeah, because IBC is now doing this stuff, so okay, a lot of this stuff moves around then, right? Really, the next is not going to depend on the input, it's going to depend on the message. I think so. So then process control buffer really goes away. Okay, so we're not going to call it process control buffer, we're going to call controller state next directly. So that is controller state. Yeah, so it's controller state next. Message. That. Copy it. Okay, and then what does handle commands do? I think this ends up getting merged with controller state next. Actually, I have to call both. We should update the controller state and I should also call handle command, right? Yes, I think so. Because in the old code, process control buffer would call controller state next and then figure out if we got a command. And if we did, it would end up pushing it onto the end, right? Or it would return it. And here's where we would push it onto the end. Only because it needed to be returned all the way out, right? And given to this handle commands, which would update the LED, update the programmer, update receive greeting and all that. Okay, so I think what I want to do is this one returns itself, right? Yes. We're not going to do that anymore. What's this U size? Consumed. I don't think I need that anymore. So it's just going to return self probably. So this would be controller state equals control state next message. Kind of like that. I think that's what I want. You already have 50 capacitors? Well, you need one for every VCC or VDD pin, right? 50 sounds kind of excessive. More, maybe you just need to increase their values. Did you say you have a RAID? Didn't I say I had a RAID? Did I have a RAID? I don't think I'd have a RAID. I think you misheard me. Okay, I don't think I need to do this anymore. Okay, I do need to run it through the programmer though. Yeah, so let's call it self.handle command handle message. Actually, handle message could also do this line, right? I think so. And I should include this. What happens if I get more than one program in here? Oh, it's gonna drop any second program. Okay, never mind. Yeah. So this really gets dropped then. Is there anything a process control buffer does other than figure out a command? It does call self-reflect serial input state on LED. What if we just call that directly? Like here. That makes sense to me. So then this is obsolete. I can delete it. Yeah, I don't think I need this anymore. Let's drop it. You said 8 to 10 VMs. Is that what I said? But 26 caps are just bypass caps for the 13 ICs. Ah, there's your problem. You have 13 ICs. See, this only has 2. Is that more than 2? Got another smaller one, so maybe 3 or 4 really tiny ones. 13 ICs seems to me to be a lot of ICs. Alright, so then I don't need this anymore. Well, what does handle commands do? This is going to turn into handle command. Or handle message, really. Okay, so let's just fix that now. Handle commands becomes handle message. So this is just message. IBC message. And so there's no loop here. It's just message. This is wrong. I need to fix that. There is a greeting, and then there are other messages. I guess we'll just ignore them. We need IBC in front. Okay. Yeah, I need to fix this. Is it time to fix this? So I might as well fix it now, right? There are two instead of one, right? Let's just call it what it is. This is program start. Or program size. And we have a usize here. Well, hold on. Usize is a tricky type. Let's just call it U32 so that it's fixed. So this one would be program sector. And this technically is, we know the size of this. It's U8 sector size. 4096. Okay, so I'm gonna have to fix a bunch of tests. Problem is that that's gonna make my test really ugly. Also, it's a large size. What if I just go to a vector of U8, even though it's not technically the correct type? Yeah, that makes the testing a little bit easier. So, okay, this is encode program size. Well, let's duplicate it first. Okay, encode program size. Let's put 42 in here because I like the number 42. So that's 342. Don't know if it's really a single byte though. It won't be a single byte. It'll be 4 bytes, right? And I don't know if it'll be little endian or big endian. Let's assume it's little endian. 2, 3, 4, 5, 6. Okay, and then we'll just repeat it here. Then we get a program size of 42. Okay, and then encode program sector. Can be as big as I want, right? So sector with that junk in it will be a 4 here. That's the only change I need to do, right? Becomes a program sector. Okay, let's see if this actually runs right now. But let me compile this as is, or we'll have other trouble. No, it just has bug on 103. Oh, in codec. Shoot. Okay, we had to fix this. Nice that it marked it for me. Sector. I was just using that for convenience, wasn't I? Back to tests and message. Run the tests. 153 in codec. Oh, indeed. Sector. Try again. Okay, so the content of the messages are different. I flipped those 2 bytes somehow on where. These are jumbled together. I guess because we have multiple threads running tests simultaneously. 0, 1, 2, 3. Wait. I'm looking at the wrong one. It's here. Oh, yeah, I did mix these up. It's 4. Shouldn't it be 4? Yeah, it's 4, 3. I had that mixed up. All right. Try again. What kind of... This is a TRS cable. But down here I also have USB-C. So I populated both just to see which one I like better. I'm getting some more flexible cables in right now. This one I bought I don't like because it's rigid. I really want like a... What's it called? Where it's like a cloth on the outside. Words escape me right now. I want a more flexible cable, and then the TRS suffers from the fact that when you're inserting it and when you're inserting it and then removing it, the wrong leads will touch the wrong parts, so you can actually short your board. Whereas with the USB-C, it's better because they all connect together, and I think the ground is a little slightly longer, so it's guaranteed to connect first, which is nice. The downside of the USB is that it's really, really tiny through-hole part, and it's harder to solder. And it's a little bit wider, I think. Tiny bit wider. But the TRS is a popular choice. The Korn keyboard I have here uses TRS. USB-C, some people like. I just put both on there just to try them both out. Braided, that's right, braided. Thank you, Endurin. Short the board. No, thanks. I don't want to short the board. I only need 4 conductors, so TRS does it, and for USB I'm using like 1/2 of the conductors. They're like another set that I don't need. Okay, so program size is wrong. 2 should be 6? What? Oh, the size is wrong. Is it really 2? It can't be 2. Does it encode it with a single byte? Right, it wouldn't have that byte there. So it would be 2? Just a 342? That can't be right. Well, 2... I don't know if this is gonna work. What if it needs to be a bigger size? I don't know if I like that. How does it know how many bytes? I guess when it's decoding, how does it know how many bytes to parse? Okay, that did pass, but then what if I use a bigger number? Like 420. I'm guessing that's 3, and then we'll have some other byte here. Let's see. What's the error? Size is okay is wrong. Shoot. So is it 2? No. Because that's wrong. I don't see how this could work if I use a U32 there. Okay, yeah, so what does it need to be then? 5, right? At least? Four, really? Okay, then what are the bytes that is... I'm confused. Oh, it's using like a variable length encoding. Well, that's sneaky. Because what is 420? Programmer. 420 and hex is 1A4. So what's A4? What's 251 actually? 1A4. 251 is FB. Clear. What's 164? A4? I don't understand this encoding at all. I don't really need to understand the encoding though, do I? What if I just get it from the test and then just decode it back? It's really an implementation detail of bin code, right? So it should be 420. Yeah, I shouldn't really need to care how many bytes it takes. Yeah, okay, I'm not going to care. So I've updated our message to have the correct things in it. So I need to update this. That's interesting. Why is this not updating? Do I need to click here? Do I need to restart the server? It should have complained that that type doesn't exist. Have a good one, Endurn. Enjoy your work as much as you can. Okay, so it did need to reload. This should be size, and then I can do size here. What? Why did I call it commit? I forget why I called it commit. I don't remember why it is commit. I don't remember why I called it commit. I'm only using it to set it there and then declare it there. And then if we get it there, then we use it to either program or wait a minute, commit now? This is wrong. This is wrong, very wrong. Am I using the state for two different reasons then? What did this used to be? Huh. Well, okay, we'll go with it. Use commit to indicate that there was a state where you would actually program the sectors. Well, but if we're getting the program and we just know the size, how would we be able to commit to reprogramming if we haven't received it all yet? You know what I mean? I must have like accidentally reused the state here. It doesn't make sense to call it commit there. Okay, I'm just confused. I'm really confused. Where does the programmer get used? It gets returned. Okay, so then it all depends on where is poll used from. Okay. We do this function next. Wait, what? Forwarding program prefix is empty. What is all this junk here? What was I doing? Right, raw slice. I don't think I need to do any of this junk anymore, right? Because we'll get the entire message with the entire sector all at once. Yeah, I think a lot of this is going to change for the better. And unfortunately, I'm not going to be able to finish it all tonight. I'm going to get halfway into it and then have to stop. Okay, hold on a second. Back. Okay. Wait. Was handle commands in 2 places? I think it might have been. Because we can get commands from this one. Or so this is all different now. Oh. Yeah. Forgot about that, didn't I? Okay. I feel like I'm making major changes to my program. Right, because we can receive messages from 2 places, from the USB port and from the TRS connector. This is the TRS connector part in poll peer serial. We could decode a message from our peer. Right. So next, I need to rewrite this, right? Because it gets a message here. And it's just returning self. We don't need to worry about consumed or command. We don't need to do any of this stuff because this is done in IBC now, right? So how do I handle this? Do I just match? I have to match on the message because if the message is program size, we go into this state, right? Yeah. But we'd first match on self. If we're in the normal state, then we're matching on the message. And here I can, thought I could, no, it's IBC message, that's why. Now I can control click that way. Field match arms, that's what I wanted. Okay, so greeting goes to the normal controller state. Well, actually, all of these do, right? Really, the only one I care about is the program size. And then we have everything else goes to controller state normal. Okay. This one's a little bit more complicated. This one ends up going to controller state receiving program size. No, we don't need that state anymore. Right, because we need to, okay. Yeah, so this is what I want. We don't need receiving program size anymore because the IBC handles that. Cool. It's actually simpler this way. So we get a size here. We log it and then we go to receiving program. Exactly. Okay, so what's the problem here? Oh, probably because I have all this junk. Can I just comment it out? Let's see. Yes, okay, cool. So if we're in the normal state and we receive a program size message, then we're receiving the program. All this junk we don't need anymore, right? Can I delete it all? I think so. Because this is not handling the command. This is just interpreting the command. We do that somewhere else now. I can delete all this. Okay, if this state doesn't exist anymore, I can delete it. Okay, if we're receiving the program, yeah, let's go and delete that state. Well, yeah, I don't need this anymore. Okay, cool. If we're receiving program, then we get the sector size that we expect. Oh, that's right. It's a good thing that I made, what is it? This thing take a vector, because it's not always going to be 4096. The last sector is smaller. Okay. Current sector. I actually don't need the current sector size, do I? We can just trust that it was given to us correctly in the message. I don't need consumed or extend. I don't even need receiving program, do I? I don't need that at all. What is in there? Oh, okay. Yeah, we don't need current sector. That's what we don't need. We need the size, because we need it at the very end, and we need the offset. Yeah, okay, got it. All right, then I don't need that vector. When we get, what we expect in this is, yeah, what we're going to interpret is the program sector. So I need to do this match again. I guess it can go here. What we expect is program sector. And then what goes in there is the guts here. So this stuff. Zero pad the whole sector, program it, advance to the next sector. And why does it say move it into place and reboot? We don't do that here, do we? Hold on. Anyway, this goes inside of here. Let that indent it in a second. So that means I can delete all this junk, right? All this I moved. All right. Okay, so we don't need this. Receiving program. It's the sector, right? I would do sector reset. So let's make that mutable, because we need to zero pad it to the sector size. And turn into a slice and give it to program sector. Okay, I guess I do want current sector size. Let's just put it here. Let current sector size equal sector size. Or sector dot length. There we go. All right. Advance to the next sector. Oh, okay. So really, this is what I wanted to do all along, but I had to split it, right? I had to put put it in a command and then return it, but we're not doing that anymore, right? Yeah, so hold on. This doesn't need to be done. Let me just comment this out for now. Here's where we would actually do what the comment says. All right, I'm slowly figuring out how to do this, and actually it's looking a lot nicer than it did before. So let's see what calls next. Here. Was it handle message that did it? Right. That's what I was confused about. It put the programmer into the commit state when we get the program size, and that's what I just commented out, right? Well, that's program command. It's not the same. I feel like I want to see what the what the firmware looked like before all my radical changes here. This isn't going to be big enough. What if I just go here and diff it this way? This looks nicer. Okay. Program with the command. It'll be a size, right? So, okay, so then down here somewheres. Not here. Oh, right, it's in another file. Okay. Yeah. Okay, so the command is program command. Oh, yeah, okay, it's just getting the size back out. Okay, that makes sense. So then, here is actually where we would move the program into place and reboot, or the other thing, right? Depends on references. Go to that. This handle message, it's this thing. Okay, so the way I had done it is we return to programmer if we're ready. And that that wound its way back up, right? Because poll, after poll, we do this advance the programmer. Right, and we either forward it or we would program immediately. So this should just be start, not commit. Starting the programmer would be, if we're the primary, we need to forward it first. If we're not the primary, we just immediately commit it. If we're forwarding it, then we go to this forwarding program state where we're sending the message down to the other guy, right? And then pausing between sectors, and when we get to the end, it's down, where is it? Where do we actually finally finish? Oh, it's right here. If we reach the end, here's where we recommit finally. So it's a separate state machine driven by a timer. Okay, I got it. Then let's go back. So that makes sense to me that this next might return a programmer. So maybe that's what I got to do. Can I just assign it back into here? No, because what if we receive more messages while we have a programmer? Yeah, that's not good. I think handle message is where we still want to do it, right? No, no, that's not right. We only have it right here. Okay. So I do want to return both self and maybe a programmer. Sort of logic here is sort of convoluted. Did I not have that correct? Wait, what? Do I need to import it? Import it. There we go. So kind of combining this part here. I need to move that somewhere, right? this needs a new home soon. I guess we could say if we got a programmer, we can call that. Okay, so then back here. So it's this, right? So then this would be new state and possibly a programmer. That means, yeah, that's a sum. So I need to have like a let mute programmer equals none to begin with. So moving the controller state machine might give us a programmer. And that happens when we get the program sector for the last sector. Yeah, exactly. Okay. Okay, so this is no warnings. Okay, back here. Okay, this is where it gets a little funny. I guess I do let new programmer here. And then I say controller state and new programmer equals. Okay, this doesn't exist anymore. This should say if, like, actually this moves here, and that just, this handle message I don't need anymore, right? Well, I need this. Oh, I also need to handle the greeting. Yeah. So this, let's pull this apart then. Handle message is gonna go away. That just turns into that, but then there's the else part that has this, and then where we used to do handle, where is it? Handle message has this programming state on LED. We're gonna do here, because there's where we turn the LED color on or off to either red. Actually, why am I putting it to red there? I don't even remember why I'm doing that. This might go away or change. I mean, this makes more sense now. We're setting the LED either to reflect a programming state or to reflect the, this is an old term. It should be the controller state. Should I just fix that while I'm here? Yes, I shall. Function 2, reflect controller state. There we go. Cool. So if we get a programmer, we're going to reflect the programming state. Or we're going to reflect the controller state on the LED. I do need to handle this greeting though. So let's just put it here. There. If let greeting equal message. Then if the message is a greeting, then record that we received a greeting. Otherwise, we're going to advance the controller state machine based on the message. We might get a programmer back. If so, we keep it, we hold on to it, and we update the LEDs accordingly. Okay, I'm liking this so far. Look for other errors. Okay, so the poll USB probably shouldn't return commands anymore. It should probably do something similar to this. In fact, this ought to be its own function that we call from two different places, right? I think so. So maybe that's the first thing I should do here is extract this as a function. Well, let's trace back through poll USB. Yeah, so this also iterates over a bunch of bytes and does something similar. Okay, then I think I convinced myself that this whole thing needs to be extracted. So extract into function. Let us call the function. What to call this function? Process control input. Sounds good to me. This is wrong. Yeah, this is all wrong. So we get a controller state in, and we're going to return a controller state out. And possibly a programmer. So that would make it look like this. Actually, the self, I don't need to do that because self is mutable, so it's already in self, right? Go to self. Here. I thought the programmer was here. Whoop. I thought the programmer was here, but I don't see it now, so maybe it isn't. I guess it's not. Where's the programmer then? Go around here until we find it. Oh, yeah, it's separately handled, passed in and passed back out. Okay, that explains it. So we do want to do that. Okay, and then what's wrong with this? Oh, because we're not returning the right thing. So it's again, let programmer equal none. I guess that means this needs to be mutable. And then we're going to end with controller state and programmer. Remove that dereference there. Take that away. This should be a sum again. Okay. What's wrong with this? It needs to be a reference. Is that right? Yep. Okay, so this is good. Just need to call it properly. So, yeah. Controller, state, and new programmer equals, and then it's the same thing here. Let mute new programmer. None. Remove that, remove that. If let sum new programmer. Maybe it would be, this would be cleaner if it was in the keyboard state itself. Maybe it should be. I might refactor that later. There we go. Okay. Does this look good now? Except for all this junk. So the idea is I'm going to call this from two places. Here and then from poll USB. Right here. So there's the input, and I do exactly that. So it's input here instead of bytes. Oh, this one doesn't return a programmer. Okay. Actually, can't I just shortcut this and just say programmer? And then put it up here. Let the mute programmer equals none. This isn't going to return a command anymore. It's going to return an optional program error. Yeah, and then I can just say programmer here, remove that, remove all this. And then down here it's just programmer. Okay. Don't need commands. You solder all the components? I did. The Fab House didn't do it. I can show you what the Fab House gave me. Hold on. There might be personally identifiable information on this thing, so let me just take it out and show you. So they gave me this bubble wrap package of 5 boards. Like this. This is what they gave me. So it has everything but the component soldered to it. And the left and the right have to be broken apart. Which I designed that part. So I soldered all the parts on there. That's why I was concerned about the USB, because it's a tiny part. Actually, I can show that to the camera, right? How small this, oh, I can't get it to focus though. How about this camera? Cameras may be a little bit better. No, it's hard to focus on it, but the through holes on this are very small. I mean, that's my index finger, right? Look how, and there are like, what? 1, 2, 3, 4, 5, there are like 8 holes all lined up together on that. Everything else was easy. The USB connector was difficult. You know what's weird is it's green, but my color key is blue. So I don't know why it kind of goes half invisible. It really shouldn't. But yeah, I've heard that some board houses can do the assembly for you, but I didn't look into that. Yeah, they are really small. You really actually don't need a microscope. What I researched on YouTube, soldering techniques, if they are to be believed, is if you just have enough flux, you can do drag soldering. And I tried that, and it actually worked pretty decently. Just look up drag soldering. It's a technique to solder either surface mount or through hole parts where it's very small, and you just kind of if you use enough flux and you just drag a bunch of solder across, it kind of sticks to each individual pin or hole. Okay, so problems resolved there. How about this? Handle commands. We actually don't get commands out, right? We get a programmer. Mute programmer. Why is it coming in and coming back out? I guess this would be new programmer. Right? Cool. Now what's down here? Because we don't need that. It's always assigned to us. It doesn't need to be mutable because we assigned it once. Okay, now what's this error? Controller state. It needs to be mutable. We're done to warnings now. Handle message is never called, right? Because we move this code around. This is no longer needed. Okay, more warnings of things that aren't used anymore. Controller state command isn't used. Right, we don't need any of this junk anymore. Cool, because IBC takes over that. Okay, what's the warning here? You should consider adding a default implementation. Okay, fine. You can do that. We just do a derive default. Right? Is it lowercase derive? Or default state. I guess I can't derive it because there is no default state. So we can't derive it. What does this say to do then? Oh, they just say add this. Okay, let's add that. There, I added it. Maybe it's happy now. Okay, back to the keyboard. Usually S&D asks people, to do them. They work with microwave boards. We're used to it. Drag soldering works pretty well. You just have to have a lot of flux, and I had barely enough. I just used the flux core of the solder I had. It would have been better, and I would have avoided the solder bridges I had to deal with if I had actual liquid flux on hand. Okay, let me review and make sure I didn't completely screw this stuff up. So in the top level poll, right? Actually, this is not the top level. Here's the very top level loop. We have an inactive programmer and a normal controller state. We're going to blink our LED, then we're going to poll. We might update our programmer here. It goes in and out. And actually, why did we pass it in? Don't need to do it this way. I guess it's I consider refactoring this later. Anyway, the old programmer might come in, a new programmer might come out. Here's where we advance the programmer state machine using a timer. Okay, now what else do I need to do? Oh, this handles all the receiving but not the sending, right? We need to actually send messages. So greetings will do that. Yeah, so we don't want to just push greetings. What we want to push is what the well, I can just do this IBC codec encode IBC message greeting. There. Why is that an error? Oh. As slice? What's wrong with this one? Okay. Cool. So that's the new way to send a greeting message. Encode a greeting and then send it to the ring buffer as a slice. Okay. I have an error somewhere. Yep, accidentally imported that. We don't need it. Okay, so that was send greeting. We also do program forwarding, right? And that happens in the programmer, I think. Yeah. So yeah, this junk we don't need to do, right? This forwarding program doesn't need a prefix. Let's drop the prefix. See what that does. Okay, so now that we drop prefix, we don't want it here. We don't want it here. Okay, so then if we're in the forwarding program state, We don't need to handle this, do we? It just needs to be, oh, this goes directly to the serial port? Ooh. Wait a minute. No, wait. I was about to say, like, we need to make sure it gets sent, but that's... If I use a ring buffer for it, it'll handle this for me, right? Okay, that's... I think I need to put that back in. I don't have it in there right now. Peer serial... TX... No, this is it, right? Where is this writer used? To send log messages, so we can do it to send programs too. And to send keys. And here's... Oh, right, we're sending the greeting. So where is the reader processed? Yeah, has the self-peer write raw. So we don't need it in two places. The programmer does it now. It doesn't need to. I just need to push it into... Okay, right. If I push it into this writer, then... And so I need to access this writer. So that means that the programmer next will need to borrow the writer. References... Yeah, so instead of borrowing the peer serial, it'll borrow the peer TX buffer writer. There we go. TX buffer writer. Okay, but I don't know the type. The type is ring buffer of that size. Like that. Import it. Yes. And import... Ooh, wait. Is that private to the keyboard? It might be. It is private. Okay, then how do I maybe just use a generic? I guess I can just make a generic. So it's generic on some ring buffer size. And do that. What is it telling me? It should have upper camel case. Okay. That wasn't it. There we go. And I can't do that. Oh, I forget how to do generics in this position. How did I do it here? Const. Okay, so it's const. Const generics. There we go. Okay, I got it working. We did it. Right, this prefix is gone. We don't need to worry about it. Yeah, this stuff is all handled by ABC now. I just need to construct the message to and then put it into the ring buffer. Oh, wait. That means the ring buffer needs to be big enough to hold it. It might not be. Okay, then, so instead of prefix, maybe I want to keep this code. Well, I want to keep this code, and yeah, instead of write raw with leftovers, it'll be like, how much can I push? Oh wait, I don't have that. That's not in my ring buffer right now. Ring buffer push will just drop everything it can't push, right? It will just do that. It'll break. So that's not going to work. Well, maybe I just make my ring buffer big enough. Okay. Let's make the ring buffer big enough. Let's completely cheat and make it big enough. So it's what size now? 2048? So 8192? Now it's plenty big enough. That just simplifies it greatly, because then in the programmer, I just put the entire message in the ring buffer, like, immediately. So then, after we write it, what do? We do this. Right, we would go to the pause between sectors, or we would be done. Okay, so all this is gone then, right? And this is writing the prefix part. Yeah, I don't need any of this then. We go immediately to this state here. What do we actually write? Oh, we have to read it from Flash. Shoot. Okay, so then, yeah. I do need this part. Just dropping this part. Okay, so then we find the next sector boundary, we find the bytes. It's not left to send, it's bytes to send, and we don't need this offset anymore. Okay, so then no, I do need the offset. Size next sector boundary minus the offset. Why did I call it bytes left to send? Oh, because I advanced the offset. Shoot. By consumed. Okay. So what we really want to know is the sector size. So this is the sector size. I don't need next sector boundary at all. Oh, I do. Actually, I don't really, because we know the offset will always be on a sector boundary. So I can just do that. Yeah, so that's it right there. It's usually a sector size, but if the program's oh, this needs to move there. Right, it's usually the sector size, but for the last sector, it might be smaller. Yes, so if we're at the very beginning, this will be too large, then we'll be using sector size. But the very last sector, this will be smaller. Okay, and so then we slice from flash base plus staging offset plus offset, and then it's sector size. So then this is what we're going to put into the program message. Right, so then what we're doing here is not write raw slice, but, and it's always going to be okay, so I can get rid of the else part. There's no if. It's just pure tx dot push. We need to take that slice and we need to put it into IBC codec encode IBC message program sector, vec, well, slice to vec, right? There's no consumed, there's no incrementing, well, if there is incrementing offset. This is plus equals sector size. What's wrong with this? Okay, yeah, it's ending up. This is doing a bunch of needless allocation, isn't it? That's okay. I'll refactor it later as slice. It's like making a vector and then slicing it. Yeah, why do we need to do this? I don't know. I'm getting confused by the error, so what I'm going to do is make it multiple lines. Oh, do I have not enough parentheses? Not enough parentheses. Oh, it's this part. The as slice goes on the outside. There. And then we need to borrow here. Okay, so this is the part I don't like right now, but we'll fix it later. The fact that we're allocating memory only to borrow it to encode, and then only using that to slice it to push it into the circular buffer. This is horrible. I was told that solder with flux core isn't that great. It's better actually use standalone flux. Probably for things like drag soldering, yeah. For normal soldering for like large things, like this TRS connector or the socket pins, it's fine. I've done it many times. The core, the flux core is plenty. Okay, what we're doing here is reading from the staging area and putting it into a message and pushing it into to give it to the peer, and then it'll get written out, right? So in the meantime, while it's being written out, we want to pause. So, or we might just actually hold on. We can't just do that. I have to move this, don't I? We need to make sure we send it all to the peer, even the last bit. So I need to move this down to pause between sectors, really. Yeah. So I should just do all of this, shouldn't I? This should just always be done here. We just sent that sector. I don't even need to do that. Waiting a bit. And then we're going to move to pause between sectors. Here's where we can add the sector size. Yeah, and then I don't need to do this. This then moves down to here. Sending next sector. So that would go here actually. And the sending next sector goes here. There's no prefix. That just gets sent as is. Okay, let's see. What do I got here? This goes there and there and there and there. Okay, so after we push the sector into the ring buffer, we're going to wait a bit because it needs to be sent and it needs to be programmed on the other side. So we start a timer, and then we go into the pause between sectors, and this, we're recording the next offset, so that when the timer's done, we say, is the next offset what's this size? We're at the size, we're basically the size of the program. Are we done? Then we commit our programming. Otherwise, we don't need this if. We always will actually, this entire thing can go. We'll always send the next sector. Exactly. Okay. I like it. I don't think we'll ever get that error, right? We're not going to get an error. Oh, wait, no. We do get the error. Error, this is weird. It's not really an error. It just means we're not done waiting. We're staying in the same state. Okay. That doesn't need to be mutable, correct? What else can we can drop the serial port, and we can drop vec, apparently. Okay, so I'm making a lot of changes and it's really scary. I don't know if this is gonna work. And I should review this and work on it later anyway. I think I'll just get the first pass done. Next stream, I will deal with the fallout of any bugs that I do, I guess. So the last thing that I need to update then would be the log, right? Oops. I don't know what I hit there. It's kind of cool, but here it is. So, oh, I didn't update poll pair serial. Shoot. I got to do that too. Did it fix me? I need to fix that. So we don't need this peer message in, actually. This will be what? A peer codec. That's an IVC codec. All right. All right. Oh, I forgot the key messages too. Yeah, so we get the bytes if it's a primary controller, else. Okay, we already had this part done. If it's a secondary controller, we actually don't use the peer codec, we use the control codec. This thing. Okay. Peer codec. Well, wait. Yeah. Yeah, okay, I understand. So then it's kind of like this, actually. This, let's just copy that. Go back and paste. So for byte in bytes, we're going to put it into the peer codec. And instead of doing all this junk, we're going to match on the message. And we'll fill the arms, and we'll get rid of this stuff. Okay, the things that we can receive from the peer that we care about are log and key. So I'm going to get rid of greeting and the program stuff. Okay, so if we receive anything else, then we're just going to ignore it. Okay, so then the key message is this part here, right? The log is this part. Okay, and then this all gets deleted. Zoop. All right, so this is the key message. The type of this is just an array of 6. So then I don't need to do any of this stuff. It just assign it to pair keys, right? Yeah, so it's just 2vec. Easy. And if it's a log, it's going to be a log message. And I don't even think I need to trim it, do I? Maybe I do. So we'll get a string. It might have a new line on the end. Actually, let's say let's not bother transmitting the new line. It's not necessary. So we'll just assume it's untrimmed. Cool. So that's much easier. Any more logs? Okay, so then I'm missing something, right? We're never actually constructing these messages. Aha, found it. Here's the next fix me. Okay, so this is just a slight change, right? Instead of doing this, we're going to take this message and trim it, right? Or am I already trimming it? Set it blah, 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 blah. Message is the length. Okay, and I do need to trim it. So message trim. And then that goes into an IBC codec encode IBC message log, and then that is message trim. And then delete that part. And delete this. And then one of these that needed to be as slice. And the message itself is borrowed, right? Okay, what's wrong here? Probably there's a comma. Expected a string found a... Oh. Shoot, so... It wants a string. Can I trim it in place? Oh, it's not a string. So it's to string. There we go. Hey there, Clayman. How are you doing? Phone screen broke. Yeah, we couldn't meet up or coordinate. That sucked. I'm sorry that happened to you, Clayman. I hope you enjoyed the TwitchCon anyway, even though you couldn't see your screen. How did you like use your phone at all then, or did you not? Okay, we don't need this fix me anymore. Okay, maybe I just search for this to make sure I hit everything, right? So there's where we push log messages. Okay, we need to, here's another one. So, let's just write this. So it would be IBC, again, codec, encode. The message is IBC, message, key. It's just, codes, right? Key, codes, codes. And encodes as slice, right? And then borrow the message. All right, what's the type of this? Expected array found an iterator. Okay, so I guess I do need to collect it. Can you collect into an array? Array of type, an array cannot be built directly from an iterator. So what do they recommend? Do I need to collect it into a vector first? and then slice it. How do we get an array? I should probably look this up rather than guessing, shouldn't I? Spent all Sunday trying to find a repair shop. 2 of them didn't have the screen, the last one did. Wow. Well, that sounds like an adventure, Clayman. I'm sorry that you had to do that. Rust. Iterator to array. Collecting iterators into arrays. Let's see what happens. Blah, blah, blah. What? Oh, right. It was try into, right? It's like... try into. Here we go. It's try into from a vector. Okay, try into. And then unwrap will crash if it's not exactly the right size array. And they don't need a slice. No comma needed. Why is it adding a comma? I don't know. Anyway, it's happy with that. If it's happy, I'm happy. How was my trip? The trip on the plane, I didn't like. Very uncomfortable. But I did enjoy meeting up with some of Adam, like with Rami and Endoran when I was there, and I enjoyed biking around Amsterdam. That was fun. And yeah. It was overall was a good trip. I just didn't like the traveling on an airplane. That was stressful and uncomfortable. I like the city though. I don't need that. Okay, what's cool is this still builds. I just don't know if it's gonna work. I have no idea if this is gonna work. It's starting to look nicer though, except for the fact that we're having to allocate memory. There's got to be a way to do this without allocating memory, right? Like, maybe I just shouldn't return an iterator. I mean, this already is an array, right? Why can't we just return an array? I'll refactor this later. We're iterating an array just to allocate memory and then trying to put it into an array again. Unnecessary. Therefore, it wasn't a mess. You know what I heard? 2 days after we left, their baggage system collapsed. So if you had to check any luggage or any baggage, you were screwed. My backup plan all along was I would take the train to... where was that again? Take the train south to Belgium and Brussels. Take the train south to Brussels and fly out of there. Okay, this is taking me way longer, and I'm gonna regret staying up so late again, but hey, I'm having fun. Why not? Search for peer TX writer and reader again, just to make sure I hit everything. So there's where we do log messages. There's where we do key reports. There's where we do the greeting. On the reader side, oh, there's where we send it over the serial port. Yeah, okay. We send it into the programmer because the programmer sends program sector messages. Where do we send the program size message? Did I forget that one? I think I did. I think I need to copy this. Yeah, I need to copy it. Okay, so this goes here. And it's not program sector, it's program size. And we put size here. Yeah, I'm missing that. So we need to tell the other board, this is the size of the program, and then we will send it its first sector immediately afterwards, and then wait a bit, and then loop that between these two states, between forwarding the program and then pausing between sectors. And when we're done, we turn our LED red and we commit to reprogram ourselves. This is actually starting to become readable. Okay, I really don't want to try running this tonight. I'm sorry, because I know I'm going to have bugs. So it's going to take a whole nother stream to debug this, I think. So I think I'm going to... What's that doing there? I think I'm just going to check this in and say it's untested, and then next stream we'll test it. I can make sure it builds. I'm just too scared to actually program it right now. I mean, it builds. It builds great. Just have no idea if it's going to work. I'm going to check it in, and then we'll go raid someone. I'll finish this work tomorrow. So this is untested rewrite of IBC in firmware. So rip out all the text line processing and replace it with IBC serialized messages. Which are processed through through a line/frame codec. Yep, I'll know what that means. It sounds complicated, but it's not really that complicated. Just ripping out old code, putting in new code. All that new code is untested. It builds, though. Okay. I think Adam in Australia is back, and I've been waiting to raid him. Let me make sure he's still streaming. He is. Okay. He just got married, like, a bit ago, like, within the last month. So I need to, like, wish him congratulations anyway. Like, it physically collapsed or it didn't function. I just read a news headline, Clayman, that the baggage system just stopped working. Like the computer system crashed, and they couldn't use it. So they weren't accepting checked luggage for any flights out of Schiphol Airport. So yeah, it was bad. All right, I gotta go to bed. I'm gonna say hi to Adam, congratulate him for getting married, and then I'll probably be back tomorrow. But you never know. But they didn't write their software in Rust? Who? Oh, the baggage guys at the airport? Probably not. Okay, yeah, it was good to see you, Clayman. Yeah, so Adam C. Eunice is a pixel artist. I really look up to him as far as how he's making his own game and doing his own pixel art, and he's a great guy, so I like to raid him when I can. He's also in Australia, so that means it's convenient for me to raid him at this time, because it's not like early in the morning for him, it's like in his afternoon. So hope you enjoy his stream. I'll catch you later, maybe tomorrow. See ya.
Primary.